All right, so I passed out the kind of the notes for our next unit. Did everyone get one of those? Okay, I also passed out page 89. We need to replace that inside the note packets instead of the 89 that's currently in there. Okay, I changed one of the problems, so make sure you have that new one in there and not the old one. Okay, this is actually not a new unit for us. This is still unit 1. Okay, so we're still going to see a lot of concepts and topics that we did on our last test. It's just that unit 1 is very, very long. So instead of covering everything at once, I broke it up into kind of 2 different sections or halves. Okay, so we're going to be dealing with piecewise functions a little bit more today. We saw a lot of those in the last unit. But this time we're specifically going to focus on absolute value piecewise functions. So only absolute values. If we were to add absolute values together, subtract absolute values together, maybe divide some absolute values, what would those graphs look like? And how can we write those as piecewise functions? That's basically what we're going to explore in this section. So to kind of kick things off here, let's go ahead and graph this individual piecewise function. How might you guys want to do that? We can plot some points. Maybe we can discuss some transformations. We should know what the absolute value graph should look like, right? Yeah? Marie?
We know that it will go to B because it's an absolute value.
Yep.
And also that it will be shifting down because of the
Okay, definitely down because of the -3. We want to take a stab at any of the other transformations? Yeah.
We'll go left 4.
Maybe it'll go left 4. Yeah?
And we have the stretch 2.
Maybe a stretch of 2. Okay, so typically what we've seen up to this point is a vertical stretch is normally multiplied on the outside of the function. Notice how this 2 is being multiplied on the inside, so maybe it's still a vertical stretch, maybe it's not. We're going to investigate that idea. We've also been talking how if we're adding or subtracting on the inside, that moves it left or right, but it kind of does the opposite of what we would think. So if we're adding 4, maybe you guys think it'll move left 4, just based off of what we've already discussed. We'll see if that actually happens. Okay, so we can maybe anticipate what some of the transformations are, but let's graph it to actually see if that's the case. So if we're not too sure about the transformations, let's just go ahead and pick some easy x numbers that we can plug in and get some values out, and we'll plot those points. Okay, so what are some easy x values that we can plug in? Pick anything you want. Yeah. 0. All right, so plug in 0 for x. We'd have the absolute value of 4, which is 4, and then -3, so we would have 1. So when your x value is 0, your y value is 1. We'll plot that point. We at least know it should be a V shape because we only have one absolute value in there. Okay, so we should be anticipating that. Griffin, you can just leave it back there. I'll get it at the end, okay? All right, let's get some other x values so we can get some more points. Another number to plug in, really easy. Do we need it up here? Okay. I saw a hand. Yeah. 1. Okay, plug in 1. We'd have 2 plus 4, which is 6. Absolute value of 6 is still 6. -3 is 3. So you plug in 1, you get out 3. Let's pick some more easy ones. Yeah. -1. All right, so we would have -2 plus 4, which is 2. Absolute value of 2 is still 2. -3, we have -1. Let's keep plotting points. We want to make sure we have a clear V shape. Right now we only have a line. Yeah. -2. All right, so -2 times 2 is -4. Plus 4 is 0. Absolute value of 0 is still 0. -3. So we got -3. Still a line. You want to keep going, Marie? Go ahead. -3. All right. 2 times -3, we got -6. Plus 4 is negative 2. Absolute value of negative 2 is positive 2. Minus 3, we got negative 1. There we go. Looks like our V is starting to take shape. Alright, so maybe that's enough points for us to just maybe connect some dots. We can figure out the leg on the left and the leg on the right. Alright, so let's see if our transformation idea here was correct. Typically, the vertex or the bottom of that V starts at the origin. It now is there. Did it move down 3 like we thought it would? Okay, so that one checked out. Did it move left 4 like we thought it would? No. How much did it actually move left? 2, right? 2 to the left. Okay, so somehow this plus 4 is actually moving it left 2. Alright, and do we still have that vertical stretch of 3? These are a little tricky to determine. What you kind of got to do is pick a good point, maybe the vertex and the other good point we found. If you calculate the slope, rise over run, is that 2? That's our vertical stretch, okay, kind of our slope idea. So we'll say vertical stretch. Alright, so really the only difference here was that left motion. So what do you think is causing, even though it's a plus 4, how do you think we can somehow get this left 2 idea? Yeah. It's because the stretch is inside. Remember how in the last unit, if we had like negative x minus 4, something like that, you would think this would go right 4, but the negative on the inside is affecting that motion, actually making it go left. Okay? The same thing's going on here. That vertical stretch is on the inside, which is affecting that left or right motion. And what's actually happening here is you have to take that left or right and divide it by that vertical stretch. Okay, that's where we're getting that 2 from. So for instance, if we had, this is going to be a little weird, but if we had 5x minus 4, okay, this would move right 4/5. Okay, you got to take that left or right motion and divide it by that vertical stretch. That's just if it's on the inside. Okay, a little tricky. We'll get there eventually when we do a little bit more with transformations, but that's kind of what's going on here. Okay, so let's go ahead and label where our vertex is, and maybe we can identify the slope of each one of these legs. The vertex looks like it's at the ordered pair -2, -3. And we calculated the slope to be 2, but that's just this right-handed leg of the absolute value. What's the slope of the left-handed leg? Yeah, it's -2. So they're going to be the same value, just one's positive, one's negative, because they're going in different directions. So we'll say a slope of positive or -2, because we have those 2 legs. All right, so what we're going to try to do is break up this absolute value v into 2 linear functions, right? Don't we have a line on one side and a line on the other? We're going to break it up into 2 linear functions and write those as a piecewise function. Okay, where does one line end and where does the other line begin? We're going to see if we can calculate that. So let's see if we check out this first line on the left. Okay, to write the equation of a line, you got to figure out the slope and perhaps the y-intercept, okay, where it would cross that y-axis. We already said the slope of this line was -2. And it might be a little tricky, but you got to think about if you were to extend this all the way down, where would it cross the y-axis? Maybe use the slope to help you out. Can you find it? Yeah. It would be -7, all right? If you continue to use the slope, down 1, right 2, you would be kind of closer to the y-axis. You'd have to go down 2 more and over 1. So down 2 from -5 would give you a -7 down there. Okay. What about the constraint? Can we figure out the domain of that line? How far left does it go? How far right does it go? Yeah. All right, x is less than or equal to -2. So this first line, if we think about our little barrier right here, where one graph or one line ends and one line begins, it shows up completely to the left, all the way towards -infinity. So you can go as small as you want, but you're not going to go past -2. And we have a closed circle there, so we need that bar. Okay, let's do the same thing, but for the other side. We said the slope for this line was a +2. This second line crosses the y-axis at 1. And what about the constraint for this piece? In terms of your domain or x values, where does that one show up? See, you start at -2 and you can go all the way to the right. Yeah. X is greater than or equal to -2. Good. We doing okay? All right. Now we're going to try to get this same piecewise function that we just did here going through a different process, okay? Because sometimes graphing it might not be available for you to try to do, okay? So what we're going to do in these little boxes at the bottom is talk about a different way we can still get the same piecewise function. I'm telling you now, they're not going to be as simple as this one. Okay, we just had one absolute value. If you flip the page for a second, you'll start to see examples that have 2 absolute values in them. Do you see those? Okay, so they can get a little tricky because you are kind of combining V shapes together, and who knows what on earth that's going to look like. So we're going to talk about this process that we can apply to any absolute value equation, okay, not just when we have one of them. So that's what these boxes are going to help us do, okay? So the first thing we're going to do, notice how this is the same equation we just did, so we should get the same piecewise function. We're going to set each equation inside the absolute value equal to 0 and solve for x, okay, just the inside. So if you look at the inside piece, that would be 2x plus 4. If we set it equal to 0 and solve for x, looks like we would get -2. All right, now let's see if we can make a connection here. Where did this -2 show up in either the piecewise function or the graph that we just did? What's that -2 representing? Yeah. Okay, it's the x value of the vertex. Okay, that's where one line begins and the other one ends. And Marie kind of also mentioned something about a changing point. Did you say that too? Okay, so notice how that's where the first piece ends and the second one begins. So it's the value of the vertex. You can also say changing spot, maybe. Okay, so that value is pretty important for us to know. Okay, perfect. Let's check out the next one. We're going to draw a number line and divide it into intervals using the values of x found in the previous step. Okay. Now, if you think about the domain of a V shape, you can go forever to the left and forever to the right. That would be all real numbers, correct? Okay, so in terms of a number line, we're going to go forever to the left and forever to the right. And we only had one x value that we found, so maybe we'll just put that in the middle. Okay, Okay, this was our changing point. So that's what I mean by a number line with the x values. It then says to write the entire equation of the function in each interval, replacing the absolute value bars with parentheses. So this original equation up here that we're trying to graph or figure out piecewise function, what it would look like, instead of absolute values, we're going to use parentheses. So on this interval, okay, on the left-hand side, we'll write 2x plus 4 in parentheses minus 3. And we're going to do the same thing on the right-hand side. Are we okay so far? Okay, we're going to do a bunch of these, and eventually I'm not going to give you the directions. It's going to hopefully become second nature to you after we do so many, but just be aware that these will not be available in the future. Okay? So what we're going to do now that we have this number line and these little intervals is we're going to figure out the sign of each expression, meaning is it positive or negative. So to do that, we're going to choose a value from each interval. Now in this left-hand interval, it's saying you can go all the way to the left, but you're stopping at -2. So I want you to pick any x value you want between -infinity and -2. Pick something easy. Between -infinity and -2. Yeah. -4. All right, so let's say we have an x value of -4. Okay. If you were to plug in that -4, okay, just inside the parentheses, okay, just inside those parentheses, so we'd have 2 times -4 plus 4. That would give us -8 plus 4, which is -4, right? So on this interval, we have a negative value. Let's do the same thing from the next side. Okay, pick any number you want between -2 and positive infinity. Something easy. Yeah. 0? Sure. Okay, we're only going to plug in 0 into the parenthesis quantity. Looks like we would get 4. So that quantity is positive. Okay, so now that we know the signs, we're going to place the sign in front of the expression on each interval. So, back to our number line up here, we said that the 2x plus 4 was negative on the first interval, but it was positive on the second. So now that we know the signs, we're going to simplify each equation by distributing, aka getting rid of those parentheses. So on our first interval, if you were to distribute in that negative that we evaluated or found, we would have -2x minus 4, and then we still have that minus 3. If we combine some like terms, we'll have -2x minus 7. On the next interval, if you distribute a positive, that's not going to change anything. And combining like terms, we'll have a positive 1. Those look familiar? Didn't we have those before? Okay, so what we have to do is take this sign chart that we developed and transform it into a piecewise function. Okay, so notice how your resulting expressions are the equations, but then the number line is acting as your domain piece. as your constraints. So notice how this first equation showed up from negative infinity to negative 2. So that would be x is smaller or equal to negative 2. And the second equation we found is showing up between negative 2 and positive infinity. So you can choose anything you want bigger or equal to negative 2. They match, don't they? We did it by hand using the chart, but we also did it based off the graph. We're doing okay? Okay, so we're going to use this chart process to help us through more difficult absolute value equations or graphs. Okay, are we ready to step it up? We're going to take a look at 2 of them on the next page. Alright, so we're going to set each expression inside the absolute value equal to 0. These are going to represent our changing points, or kind of our vertices, where one line ends and the other one begins. We have 2 absolute values, so we're going to have to do this twice. So that means we're going to have 2 changing points. Looks like we have negative 4 and 1. Alright, so let's go ahead and write our number line, going from negative infinity to positive infinity. And we're going to label negative 4 and 1 on that number line. Okay, so we have 3 sections. We have negative infinity to negative 4, we have negative 4 to 1, and then 1 to infinity. So inside each of those intervals, we're going to rewrite the original problem, but instead of absolute values, we're going to use parentheses. So parenthesis x plus 4 plus parenthesis x minus 1. Okay, inside each interval. You might have to write a little small. Note to self to give you guys more space in the future. Alright, so now that we have our number line set up, we have to figure out which of these quantities have positive values or negative values within that interval. Okay, so our first interval from negative infinity to negative 4, pick any number you want between negative infinity and negative 4. Something easy, yeah. Negative 6. Alright, so maybe I'll write that up here. X equals negative 6. That's what we're picking. Okay. If you were to plug in negative 6 into each parenthesis, okay, individually, negative 6 plus 4, positive or negative? Negative. Okay, so we're going to put a little negative out front. Negative 6 minus 1. Positive or negative? Negative. Okay. We actually wrote out the work last time, okay, but I think you guys could probably do some of that in your head. You don't have to write it down if you don't want to. Okay? Pick any number you want between negative and 4 and 1. Something easy. Yeah. Negative 1. Okay. You could pick 0. You could pick negative 3. Anything you want. Alright, so plug in negative 1. Negative 1 plus 4. Positive or negative? Positive. Okay. Let's see. Negative 1 plus 1. Oh wait, that should be minus 1, right? My mistake. I was wondering why we were getting 0 there. I copied that wrong. Alright, that should work better. Negative 1 minus 1. Positive or negative? Negative. Okay. Next interval, pick anything you want between 1 and infinity. 2? Alright. 2 plus 4? Positive? I don't care what the number is, so we're just looking for positive or negatives. 2 minus 1? as positive. All right, so now that we know the signs, we're going to simplify each interval individually by distributing in those signs that we found. So our first interval, we have to distribute in the first negative and the second. They were both negative. And if we were to combine some like terms, we'd have negative 2x minus 3. Okay, so that's our first equation in our piecewise function, now that we simplified it. If we continue through the next interval, we can distribute in a positive, but that's not going to change anything. Then distribute in the negative. Combining like terms, looks like the x's are going to go away and we're just left with 5. So that's our next piece. And the last section, distributing in those positives, is not going to change anything. So combining like terms, we have 2x plus 3. There's our third piece. We're doing okay? All right, so what we got to do is finally bring this number line, this kind of sign chart together and analyze it so we can write our piecewise function. So we have 3 pieces, the negative 2x minus 3, the 5, and the 2x plus 3. And then we're going to use the number line to help us figure out the constraints or the domains. So our first equation, negative 2x minus 3, showed up from negative infinity to negative 4. Can we represent that in our domain section? You can pick anything you want less than negative 4. So x is less than or equal to negative 4. Our middle piece of 5 showed up between negative 4 and 1. So we can write that constraint. And our last piece showed up from 1 to positive infinity, so anything greater than 1. Make sense? Can we analyze that number line? Okay, so let's go ahead and see what this graph looks like. We are combining 2 V shapes together, so it's not going to be a perfect V. It might be a little different, but let's see what this looks like. Now that we have the absolute value equations, we should be able to graph it, and I'm actually going to show you how to do it on a calculator, okay, to check your work if you want to. We'll get to the calculators in a second, okay? Let's go ahead and label our barriers or changing locations. We have negative 4 and 1. Okay, let's get our, maybe you want to label the sections where they show up. I know some of you like to do that. If we look at the first equation, we can plug in negative 4 to kind of get a starting point. So negative 2 times negative 4 would give us positive 8, minus 3 would give us 5. So negative 4, 5, we'll have a closed circle. So that's the only point value we get based off of the domain or constraint section, but we need some type of other point on there to help us guide the line. What else can we use to help us find another point? Yeah? 1? Okay, well, we'll get to 1 in a second when we deal with those. Okay, but we're still trying to graph this one. What do you want to do? Yeah. Alright, let's go ahead and use the slope. Because from this point, we know we should be able to go down to right 1, but notice how we're not in the correct section of the graph. So we're going to have to use that slope backwards. We'd have to go up to left 1. So there's another point in the region that the first equation should be in. So you can connect those 2 points. So the slope is one way you could find another point. Another way is by simply picking any x value you want that's less than -4. Okay, you can choose -5. If you plugged in -5, you can get another point that way. Okay, so choosing an x value or using the slope, 2 different methods. Alright, let's go ahead and graph the second piece. If you tried to plug in -4 for the x, there's no x there for you to actually plug it in, so the only y value you'll ever get out is 5. So if we try to plug in -4, we're only going to get out 5. Notice how we already have that closed point there. Same thing with 1. If you tried to plug in 1, you can't, so the only value you'll ever get out is that 5. Okay, playing connect the dots, or maybe picking any number you want in between -4 and 1, no matter if you tried to plug it in, you'd always get out 5. So you're going to have this flat constant function. If we try the last one, plugging in 1 would still give us 5. That point's already there. But maybe you can use the slope, up 2 over 1, to get another point. So there's our absolute value-ish graph. Kind of looks like a V, doesn't it? But it's slightly changed because you're adding 2 V shapes together, and how that works is going to be different for every function. Okay, so let's go ahead and talk about domain and range. Now that we have a graph, okay, think about tracing with your pencil. How far left could you go? How far right could you go? Do you have any breaks in the middle that you have to be worried about? What can we say is our domain? Yeah. Negative infinity to positive infinity, aka all real numbers. Maybe some of you want to write that double stem to R, means the same thing. Alright, what about the range? Tracing low to high? Yeah. 5 to infinity. Okay, what about brackets or parentheses? Bracket on 5, parenthesis on infinity. We doing okay? Alright, so what I want to do is try to show you how you can get this same graph on your graphing calculator. So if you have one available, go ahead and grab it out. If you don't, you can go ahead and grab one on my door. Alright, so turn it on, make sure it works. If we're going to graph something, oh, it's been a while since we've used calculators. Do you remember where we go, what buttons we have to press to graph something? Maybe? Shaking your head, yeah? The y equals. Okay, so y equals, very top left-hand corner. If there's anything in there, go ahead and clear them out. Okay. What we're going to do is simply graph the original function. Okay, I'd rather graph one thing than having to graph 3 separate ones. Okay, so we're just going to graph the original to see if it checks out with the piecewise function we drew. Now the original equation's at the top of the page, those 2 absolute values. We need to somehow tell our calculator that we're working with absolute values, so there's a particular spot you have to go to on your calculator. I want you to hit the math button right underneath that alpha on the left hand side. Right now, math is highlighted, but I need you to scroll over to number. So use your arrow key to do that. And notice the first option, ABS. You see that? Okay, the calculator's not ripped, it doesn't have any abs, okay? That's standing for absolute value. So we're going to hit enter, and notice how it would bring up those bars. Okay, now depending on the operating system, it might not bring up the bars, it might just say ABS. Does anybody say that? It's okay if it does. Does it say ABS with parentheses? Okay, so you're just going to type in x plus 1 or x minus 4 into those parentheses and close it off. Okay, so inside those bars, we're going to go ahead and type in the first x plus 4. But we need to get out of those absolute value bars, so you're going to use the arrow to bring the cursor more to the right. And then we got to add another absolute value, so we have to go back to the math button, over to number, and select ABS again to bring up another set of bars. And then we'll type in x minus 1. Okay, so math over to number, it's the first option, ABS for absolute value. Maybe you want to write down those steps. Okay, before we hit graph, let's go ahead and select our window to make sure we can appropriately see this. We're trying to compare the graph we drew to the graph that we want to find on the calculator. So let's use the window that this graph on our paper currently has. Notice how we're going from -9 to 7 on the x-axis. So we'll set -9 as the lowest x and 7 as the highest. And we'll count by ones. In terms of the y-axis, we're going from -2 all the way up to 14. So -2 is the lowest y and 14 is the highest. And we're still counting by ones. So with the equation in there and your window set, go ahead and hit graph. That looks pretty good, doesn't it? So I say we found the piecewise function correctly and we graphed it correctly. Okay, so if you have a calculator, you can check out to see that your graph and equations were correct. Alright, maybe we'll write down those buttons. Okay, so absolute value on the calculator, you have to hit the math button. You scroll over to number, it's num for short, and you want to select the first option, okay, ABS, to bring up those bars. We hanging in there? Alright, we're going to do a little bit more with these tomorrow. Okay, just practicing setting up the number line, okay, finding the piecewise function, possibly graphing it. Tomorrow is basically going to be a practice day. Okay?